In this video, we're going to go over just the basics of how to use financial calculators to do some of our time value money calculations. So I've got an HP 10B2 and a Texas Instruments BA2. These are almost identical. There are some slight differences in the way you enter information, but the way you use these two calculators is 90 to 95% exactly the same. So we're going to talk about how to get these things set up and the basics of how to do time value money calculations with these specialized calculators. So turn them on, you hit the on button, so you've got a little information saved in here. So the first thing I'm going to show you is how to get your calculator set up, because there are some settings that can operate some things behind the scene, and you just mostly want to make sure that you don't have anything going on that you don't want there. So the first thing that we're going to do is change the decimal places to give you 4 digits. So this has 4 digits. Now on a Texas Instruments calculator, the way you're going to do that is you hit the second key, and you can see right here above the decimal it says format. You open that up and it says, okay, here's how many digits you want this to have. So if I wanted to change it, I could enter in 5, and you can see it gives me 5 digits. Now I want to leave that at 4, hit that enter key, and that's done. Now on the HP, it's going to be very similar. You can see I've got 5 digits here. So what I'm going to do, I'm going to hit the red shift, and then here on the equals key, you can see display. I hit that, and then I hit the number 4, and it reduces me to 4 decimal places. Now I've got the same number of digits on each one. Okay, the next thing that we are going to set up is the periods per year setting. All right, now these calculators have settings that will allow you to change the number of periods per year when it's doing the math. But we do not want to use that setting. It's just going to cause you problems in the future. So you want periods per year to always equal 1. So the way you get that set up. So on the HP, if you want to know what your settings are for periods per year, you can hit that red shift and hit clear all, and you can see it says, okay, we've got 2 periods per year. Want to change that to 1. So I'm going to hit 1. Then I hit that red shift, and then I'm going to hit that payment key. And now, whenever I do the clear all, you can see it says 1 period per year. On the TI, well, the setting is above the I/Y key. So I hit the second, hit that key. It says, okay, I'm at 1. If I wanted to change it, I would just push in the number. So if I wanted to change it to 12, hit the number, hit enter, there it is. I want to go back to 1, there it is. Okay. And then the last thing that you might want to check is if it says BGN anywhere. So if I turn that setting on, okay, now you can see it says BGN there. We want to turn that off. And again, on the HP, it's going to be very similar. So the way you turn it on and off, well, on the TI, I need to go to this little BGN that's above the payment key. So I hit the shift, payment, then I'm going to hit shift enter, and you can see that says set, and now I'm in ending mode and it gets rid of the BEG. Here, red shift, hit the MAR key, and you can see it says beginning/end, and that gets rid of that. So you shouldn't see anything. We should be in ending mode, and that controls the assumption about where do cash flows change hands. Do cash flows happen at the beginning of a time period, or do the cash flows happen at the end of a time period? Standard assumption is cash flows occur at the end of each time period. So if you start from today, the first future cash flow is at the end of the first year. Beginning mode says the first cash flow happens immediately. It's not a big deal, but you just want to definitely make sure that you're in the right mode, because it will change the answer that the calculator gives you, so you just got to make sure you're in the right mode. Okay, so the next thing we need to look at is doing time value money on these calculators. You spent the money, it's a financial calculator, what does that gain you? Well, what we can see is these calculators each have these 5 keys, right? N, I, PV, payment FV. All right, now this is the time value of money section of each of these calculators. These keys correspond to our time value of money formula, right? So you've got the lump sum formula here, all right? And then remember we also did annuities, and the formula for an annuity, right? You had C over R times 1 minus, right? And here you had 1 over 1 plus R to the T, all right? And that was our annuity formula. These keys correspond to the things that we have had in our time value of money formulas. So this N key, right? N is equal to the number of periods, okay, which corresponds to the T. Now, the way I've got this arranged, whenever I set that periods per year to 1, this basically turns out to be M times T, right? The number of compounding periods in the problem. That's what you put for N. The I is equal to R, and again, this is the periodic interest rate, so it might be R divided by M if you have more than one compounding periods per year. The next thing is the PV. Well, PV is the present value. Then you've got the payment key. The payment key corresponds to any cash flows in an annuity type function. So it would be a constant recurring cash flow that occurs each time period from now until T, right? Payments. And the last thing, FV, well, that is equal to the future value in our equation. And so we enter in information of these keys and we solve for values in answers. All right, so let's do a couple of small examples. Whenever you're doing a problem on your calculator, it's often helpful to write in the information that you're about to enter to make sure that you don't leave anything out and that you know what you did. That way you can check for errors and make sure your calculations going into the calculator are okay. So let's do a very simple little problem where we want to know if we make an investment of $150 today, all right, how much will the future value be if our interest rate is 5% per year, and let's say that there are, I don't know, 3 years. Okay, well in that case we want to set our N equals to 3, right? We've got 1 period per year. We didn't say anything about compounding, so let's just say that there are 3 years. The present value, now if I'm going to make an investment, I have to give up $150, so I'm going to say negative 150 is my present value. There are no recurring payments, right? It's just I give up my money today, and in 3 years, I get back some money. So I'm going to set that to 0, and I am trying to figure out the future value. The only last thing is, all right, well, the I is, well, there are 3 periods, right, 3 years, and each year I get 5% interest, so I'm going to enter that as 5. So over here on our calculators, the first thing we want to do before we do any problem is I want to make sure that I clear out any information that was saved behind the scenes, because your calculator will keep numbers in here until you change them. So to clear that out on the Texas Instruments, you hit the second key, then we hit FV, see it says clear TVM. Okay, and then over here I'm going to do Redshift, C, it says clear all. All right, and it'll flip through and say, okay, you've cleared everything. So let's enter N equals 3. So I do 3N, same thing here, 3N. I is 5, 5I, 5I. PV, negative 150, 150, negative PV. 150, negative PV. Payment, 0. And then FV. All right, now I need to solve for this. On the HP, I have entered in these 4 keys. I can solve for the 5th one, so FV. Here, I'm going to hit compute FV. Same answer, right? 173,6438. And there's my answer, right? And I mentioned, since you've entered in 4 things, I can solve for the 5th. Because these keys correspond to equations, it works just like you learned in algebra. If I've got one equation, I can only solve for one unknown, which means there are 5 things that are possibly in my equations. I have to know 4 of these before I can solve for the 5th. Now, noting that both of these represent future values. These are payments and these are, lump sum future values. The intuition of this comes from our time value of money formula, right? There are 1, 2, 3, 4 things in this formula. I've got to have 3 of them before I can solve for the other one. Well, the payment and the future value here are just 2 different types of future cash flows. So I've got to have 4 of these things, and then I can solve for the 5th in the calculator. That means I can solve for any one of these 5 if I have the other 4 numbers. All right, and then your calculator can do anything. We don't need all those equations all the time. We can just let the calculator at this point do the math for us. So let's do another example, except for let's solve for something else. Let's try to figure out, let's do something complicated, right? Because we've got the calculator. We can do kind of whatever we want here. Let's do an annuity. Let's do a home loan, right? So a home loan is going to have 360 periods, right? And this represents a 30-year mortgage with 12 payments per year, all right? And let's figure out how much house can I buy, okay? The next thing we would need to know is, well, what interest rate is the bank going to give me? And let's say that, the interest rates in the market, they're saying that they can give you a loan for 4.5% per year, right? They're telling you an APR. Well, if I divide that by 12, that will tell me the monthly rate. Okay, well, I'm going to have to go into my calculator, right? And so that is 0.375%. And if you notice, whenever you enter these interest rates, you enter them as whole numbers, right? If I were going to put in 4.5, I wouldn't put it in decimal form. I wouldn't put 0.045. I just put in 4.5. So here, this is 0.375% interest per time period or per month. The next thing that we would need to know, and I guess I should go ahead and put in our number of time periods. We are trying to figure out how much money I can borrow, which means that's money that changes hands today. I'm trying to calculate the present value in this situation. Now, in order to calculate that, I need all that other information. Now, the future value is a lump sum payment at the end of this loan. Well, mortgages don't have that because all of the value of the loan gets paid off with the constant payments. So you say something like, well, I can afford $1,500 a month, and I'm going to make that negative because I'm willing to give up $1,500 a month each month for 360 months starting from today at this rate of interest. How much house can I buy? How much loan will they give me? Well, enter in our information. And then, what's the present value? Compute PV. You can see we would be able to borrow, and it's a positive number because we would receive this cash and then we'd pay for the house. $296,042.74. And that's how much house we could buy, right? If we wanted a $300,000 house, maybe, we put in some down payment. We didn't work through it in that much detail. This is just looking at, hey, that's how you enter in the information, and we can solve for present value that way. What if we wanted to know something else? Let's solve for another letter, another key on our calculator. Let's say that we are willing to, we're going to try to save some money. And the thing is that I've got $5,000 and I'm willing to give that up today. I'm going to put it in an account where I'm just going to leave it and I'm going to let it grow. I'm not going to make any other payments. I'm not going to withdraw anything until it hits $10,000. I want to see how long will it take my money to double in value. No payments. So the next thing is, well, what's our interest rate? How many periods is it going to be sitting in that account? Let's say that the bank is offering 2% per year. So let's say that that is with monthly compounding. All right, well, our interest rate is going to be 0.1667 per month. And you can see that I did the math and then hit this rather than just keeping the 4 digits. I want to make sure that I keep as much accuracy as possible. And since I've only got 4 digits here, it could be that there are actually more digits. They're just being rounded. So you always want to keep as much precision as you can. The next thing is, well, I want to know how long it's going to take. So let's put our information in. Right, so we're going to give up these present values. There's not going to be any payments. And we want to see, hey, want to make our money double. All right, how long is that going to take? Compute in. Well, it says 416 let's call it 25 in. Well, this is the number of periods, and since we had 12 months per year, I actually, this is the number of months. Okay, so if I want to know how many years, I would actually need to divide this by 12. And it will take me 34 and a half years, right? Because if you're only getting 2% per year compounded monthly, it's going to take a long time to double your money. Now we can look at what happens if I can get a better interest rate. Right? What if I can get 10% per year? Well, what we would need to do is update our interest rate, and then we would recalculate the number of periods. I don't need to update these values because the only thing that's changing is I'm now going to get 10% per year, and there are 12 months in a year, so I'm getting 0.83% per month. All right, then we recompute our in. All right, so it is 83 and a half months, which would mean a little under 7 years, right? Takes about 7 years to double your money if you're getting 10% compounded monthly, right? And so that's pretty cool, right? Now look, you can solve for anything. You can solve for interest rates. You can solve for payments. You can solve for all kinds of things as long as it fits the problem that you're facing. All right, so that's the basic time value of money functions on your calculators. In the next video, we'll go into the more advanced and more specific functions and look at how the calculator can help us with a couple other types of problems.